Hi everyone, we talking about in the lecture number 3 is environmental pollution. The last lecture number 2 we talking about the Goldsmith classification of our periodic table and our elements famous in our crust or core or atmosphere or hydrosphere. So we now discuss what is the environmental or environmental pollution, which is talking by these elements. What is the effect of these elements in our life and in our environment, and what is the behavior of environmental geochemistry. So the question now, what is the relation between the Earth's element contaminations and soil? What is the form of making or causes contamination in soil? What is the contamination of groundwater? What is the nutrient food contamination and the pollution to our us from all these elements of the Goldsmith and periodic table? So the pollution found in all media, as you know, we have a noisy, what is called sound, like view, what is something not like. So it is pollution found in all where in our earth, as you know. So for me to know about what is the contamination and what is the pollution of these elements affecting on our life. So now we have some element make pollution to the ground or the soils or groundwater or the soils, like mercury, lead, fluoride, dioxin. Something is cadmium or what is called air pollution, arsenics, asbestos. The material asbestos is a mineral, metamorphic mineral, which causes many pollution of our benzene or something, petroleum, something like that. This is what is called the chemical of public health concern about our life and our civilization. So, as you know from your knowledge before, the soil or clay or something like that, which are using in agriculture and which are using in life on Earth, it's forming of many here of heavy metals which have maybe contaminated it. Heavy metals about contaminated the soil about by percent of 35%. Coming from the here and mineral oil is forming about 24%, and the other materials you see from 10 to 11 and 1% phenols and something like that. So it's the soil, and our soil going contaminated by many things of our life using, like heavy metals and mineral oils, as you see, as petroleum, benzene, coals or something like that, which are giving us the energy. And in groundwater also we have the same percent, but it's different in percent. Here is about 35, here is about 31. Okay, what is a contaminated or make a pollution for the groundwater, also make a contamination for the soil. Also mineral oil here is 22, but here in 24. It's not difference there. Okay, also another phenols and something like that, 1% is the same. So the elements which contaminated the soil, of course contaminated the groundwater. You see the combination between these elements together to each other. Okay, considerable research into the global environment is now being undertaken, especially into issues such as we are talking about contamination, climate change, what is the factor going to be contamination or pollution in our life, climate change, biodiversity, and water quality. Water quality is very important to us to live. So it's now what is called water war. Water war is coming of us. If you are want or non-want to it. But the water quality is very fantastic. Here we discuss into the repurification or purified water, especially what is called the Ethiopian dam, something like that, make affecting maybe on the contamination of water coming from the Nile River. Okay, relatively little work here was being carried out on the sustainability of the Earth's land surface and its life support system. However, other than on the basics or response problem, we have some problem in some mines, something like that. Mercury, you know that mercury Hg symbol in periodic table, Hg, it's make a contamination, poisoning related to when are you purified the gold or arsenic gold, which are making some poisoning of by arsenic or what is called mercury poison. So which this is material, of course, it's distribution to the groundwater. Of course, it's when you have a mine of gold, you purify the gold to have a metal, precious metal. This is drop of arsenic or mercury here, the arsenic of the mercury elements. Okay, you know, okay, arsenic and mercury poisoning. This is the problem of like in Bangladesh, like in scientists Medley 1999 search going to be emphasized on this arsenic problem. We have mercury now and arsenic add two elements which going to be make some pollution in our soils and water. So development of policy of global of the earth scale depend on individual going to be environmental sustainability. So we first review some of the factors which are leading to degradation of the earth. You know the earth in normal state, it's a good one, but degradation is going to be degradation of the earth land from the contamination or pollution in industrialized countries. This is the country which use many factors and going to be produce some product materials to export to us. So it's called industrialized country, like Italian, like most of Europe, Germany, British or something like that. So the material which has the elements which have going to be degradation of the earth in industrialized country and in the tropical or equatorial and arid terrain typical of the developing country maybe causes some contamination, and to consider some of the environmental geochemistry problems and approaches present used to try to mitigate them, particularly by the geological survey working on the behalf of the national and international aid agency. You know, in some developing country like something in countries of Africa, it needs something help, so it is called some agency in the world going to what is called the International Aid Agency, which has provided some fund of this country to overcome on the contamination of this arid area or which have geochemical problems. So the value of a strategic geochemical database in this discussion based on the program, some programs of aid agency like in British Geological Survey (BGS) and the United States Geological Survey (USGS). So it is this is state going to be provide some research about the contamination of the environmental geology. Finally, global geochemical baseline program of this is two agency like IUGS and IAGC is described with particular reference to the standardized of the chemical survey methods worldwide according to over the country, and the provision of the global reference network. Global reference network here is against which new and available national regional geochemical database can be lived. So we collected the data. We collected data from this is all agency of the international surveying geological survey companies or United Union here. So we collect the data. What is the data? Is the behavior of the chemical elements on the Earth's land surface. Okay, so what is the pressures on the surface environment of industrialized and developed countries? It's making a pressure on our life. So annual increase of the world population approaches all the population increase about 80 million per year. 80 million per year we increase in the population and the number of the human being lived on the Earth's surface here. 80 million per year all over the world. As a United State, as United States here is 1998. Approximately of 90% of which is the poorest country, you know, the poorest country of in Africa, on American, Latin America, on India or something, Bangladesh, something like that. 90% of this is poorest country, where one quarter, it's one of quarter of the population lived in absolute poverty, having annual income below $450 per year. Yeah, okay. If you are make some man work in some country, developing country, and your salary is less than $500, you are having a problem. What is called, you are in poor country, as defined by the World Bank in 1998. Okay, it's 500. It's equal about 7,500 Egyptian pound. It's maybe less about what's called 60, 65, 60, 50, 650 of Egyptian per month. By the middle of the next century, world population is projected to almost double that the 19th United States of United Nations. So United Nations 1998. Also the relative distribution of wealth. What your wealth in prediction to be similar to the present day. Some countries have a wealth, some countries have a poor. So hence here is estimated by the end of the next century approximately 8 out of 9 people, 8 of 9 people will live in poor developing country. Okay, it's a high percent, like Africa, Latin America, much of Asia, like Bangladesh, India, something like that, or compared to approximately 1 in 2 in. Okay, now the rate of the poor is increased than before. Before in 1950, the 1 of 2, maybe 1 of 2, but now it's 8 of 10. 8 of 10 now. Okay, so we have problems. You see here this is the world ratio of the millions of years according to the poor and the wealth poor country. This is all the world. Solid line is the world, and this is third world, like us here. Third world is the dotted one, dashed one. But industrialized is have the lowest of the population here in millions. Okay. So you know from your knowledge that all population in Europe is less. Okay, pressure on the surface environment are different in each industrialized countries, compared to those in poor developing country. Okay, of course, we in poor country have some pressure on our life. Industrialized countries have frequently had a long history of mining and mineral work. And America as British or Germany or something like that. Manufacturing in intensive agriculture, forestry, and urbanization, like in Europe. In Europe, for the example, which is the one of the most densely regulated contents. So and is also one of the most intensely utilized land area on the earth, and increasingly important problem needed to redevelop the derelict and contaminated land. So if you have many factories on the land, you must be contaminated of your land. Of course, this is a fact. This is becoming more difficult because of tighter legislative and fiscal controls, especially in the introduction of the triggers and action levels. So the harmful elements here, species like PHES, which are being used to increase the as integral part of the planning and management process. We see here the table of the essential elements to the animals and vegetation. Animals and vegetation. This is the principle of our life here. We have also two major elements. Major elements types of elements. Major elements which have a blue color. Major elements like magnesium, sodium, carbon, hydrogen, nitrogen, oxygen, potassium, calcium, phosphorus, silicon, and also trace elements like chlorine, manganese, zinc, copper, iron, fluor, chrome, brom, molybdenum, cobalt, vanadium, iron, lithium, aluminum, nickel, strontium, barium, rubidium, tin. All this is element is a trace element which found in animals and vegetation. So of course, animal eat vegetarian or animal which eating most of vegetation, and another animal eating animals, something like that. So we have the same element transfer from the vegetation to the animal. So you know the first food we are talking about in the triangle of the food we study in science. It's started with the first producer, which called vegetation or plant or plant here. Plant here is the first producer in our nature. So the first producer, first customer here is the animals which have eating the vegetable or plant, and the second customer and third customer until to reach the human being is the last customer who uses all the animal and vegetation. So all this is element transfer from the land to the plant, and then to transfer to the animals and transfer to us. So it's going to step by step. So all elements which have a uses in our body or customers every day, we are consumed from our plant and the animals. So the pattern of abundance of elements. What is assimilation increase? Assimilation increase what is called macronutrient. What is nutrient? Nutrient is the equal food, but nutrient is a very useful word about what is the extraction from your food. Extract from food is called the nutrient. Nutrient here in Arabic al-mughaziyat. So you have macronutrients and essential micronutrient. Micro is a small one, macro is big one. So we have carbon, calcium, chlor, phosphorus, magnesium, potassium, sodium, sulfur, oxygen, hydrogen. This is element is called macronutrient, which is entering all our food we are taking in our life. So not for us, also for the animals. So it's a good one for middle using to this is material, not make a deficiency or making increasing, and it's going to make some problem. Every element you are used, it must be balanced in your body. Some increases is making problem, and some decreasing also making a problem. So essential macronutrient, this is macroneutral in all talking about. But essential one, micronutrient, is about micro here is small one: chromium, copper, and iron, manganese, molybdenum, selenium, vanadium, zinc, fluorine, iodine, silicon, cobalt, arsenic. This is very small little amount of nutrient in our life and our food. It's good, but if you have exceed of it, maybe have a toxic state. Toxic state is going to be somebody have deficiency of this element to make some diseases. Deficiency here make some diseases here, like iron, like copper, like one which we discuss in this lecture what is affected in your health. So if you have more of these elements, we will be going to be a toxic state. Toxic state that may be reached to die, and loses your life. So non-essential elements you have or not, it's not affected, but sometimes exceed of them is going to be a toxic state. But presence of highly of amount may make terrible for you. It's beryllium, cadmium, like mercury, like nickel, lead, stibnite, tin, or titanium. This element is very low amount, and we don't need, in fact, like beryllium, cadmium, mercury, nickel, lead, stibnite, or tin or titanium, etc. like this. This is maybe making you for you. If you have enough amount, it may be terrible. If you have much amount, it may be toxic. Maybe some poison for you, so you must be careful about this. So what is the importance of this element in our life? Calcium here is strengthening of bones and teeth. Is calcium used for your teeth and your bone here, so it is you make a skull or every bones in your body. Muscular activity is controlled by calcium. Blood coagulation, it's calcium helping in blood coagulation. So it's cellular permeability. Excess may be originated liver and bladder stones. Your liver is the factory of your body, is originated liver and bladder stones. If you have more excess feeding of your calcium, maybe some troubles making bladder stones. You are kidney stones or something like that, and renal insufficiency. Renal insufficiency not going to be good. So you must be careful for eating much more calcium. So chlor, maintenance of blood pressure. It's keeping the blood pressure in normal good one. Vital as acid constituent during digestion. It's during digestion, making the stomach juice is what is called the hydrochloric acid. It's a dilute hydrochloric acid. It's need chlorine to making this. Potassium also is very important element because making maintenance of the corporal fluid, which have associated with the fluid of balance. Muscular contractions, and the nervous impulses. This is nervous system. You need potassium. Potassium is very important, like in banana. Potassium, like in banana fruits. Magnesium with calcium. It must be important in our bones. Here together with calcium. So activation of muscular contraction like calcium, muscular acceleration like potassium. Here body temperature controls. Magnesium is very important element in the immunity also, المناعة. So it is temperature control component of several enzymes. Maybe enters to component of several enzymes which are the body using for the digestion and making blood circulation. This is enzymes may be control of your body life. Sodium. Nobody can remove sodium from his foods every day, especially in salt. Salt, is sodium chloride here. So active in hydrosaline equilibrium, you need some amount every day of sodium. it's make hydrosaline equilibrium, especially in your brain. If you don't taking sodium many days, maybe going to be amazing, maybe going to be reach to lose your controls. So transmission of nervous impulses, it's control of your nervous impulses and the transport of metabolism. It's a very important element here is sodium, especially with potassium and magnesium. This is the three factors, three elements here: potassium, magnesium, sodium. Is the factor of your life, daily life, every day. So phosphorus here, bone constituted as apatite. So you know this is phosphorus found in apatite minerals, particularly in most of body chemical reaction. It's very important in most body chemical reaction. Excess of these elements maybe turns hair and bones brittle. Your hairs, like me, turns to be, and bones, not me, to can be brittle. So you need phosphorus for your healthy of your hair and bones. Okay, we continue in the importance of element here. So cobalt here is important in active combination of vitamin B complex and the chemical reaction. Deficiency causes in vitamin B12. Deficiency causes anemia. You know anemia is deficiency of iron. Excess of iron causes heart failure. It's called what is called iron poisoning. So we're talking about chromium needed for metabolism of sugar in your body. All your food transfer to sugar, what is called blood sugar. So metabolism needed chromium for the completing this process. Deficiency maybe causes diabetes. Deficiency maybe causes diabetes. Intolerance to glucose, etc. Maybe intolerance to glucose. Excess of chromium may be result in the renal failure. Renal failure is a kidney process. Excess of chromium 6, you have no chromium 4 and chromium 6. Chromium 6 is carcinogenic, maybe carcinogenic according to your heart. Copper is the important component of the oxidizing enzymes during the metabolism of the energy source. Active in the synthesis of the hemoglobin. Copper is important for the formation of blood hemoglobin in the keratization and skin hair and hair pigment. Copper is very important to maybe making keratin for your hair and your skin. So and hair pigment color. Deficiency of these elements lead to osteoporosis and a low number of white blood cells. So it's it's going to be important for the blood formation cells like white blood cells. Fluorine gives strength to teeth and bones. Is associated with phosphorus and the calcium. Give strength to teeth and which have many. You have good teeth, you have good fluoride. So it's used in the brushing of our daily using. So giving strength to teeth and bone, avoiding dental caries or cavity, which are keeping the health for your teeth, and osteoporosis. So excess of fluorine causes fluorosis. Fluorosis or fluorosis is of teeth and bones. Maybe in Arabic it's called falwara of teeth and your bones. So iodine required by thyroid hormones. You know the thyroid gland here. Thyroid gland here is very important for iodine elements. So temperature control, which are control your body growth, reproduction, عمليات التكاثر, etc. Deficiency causes abnormal growth of the thyroid, abnormal thyroid here, making by deficiency of your iodine content in your body. So we are completing the elements which are controlling, affecting controlling in our life here. Now we're talking about the iron here. We're talking before cobalt, now we're talking about iron, essential component of hemoglobin. So it's cobalt and iron is very important for hemoglobin and making what is called anemia. So and enzymatic complex required for energy generation and immunological system. Immunological, which what is called جهاز المناعة, it's very important for the needed iron and cobalt. So manganese here is a promotion of growth. Now we're talking about manganese, which is promotion of growth and development. Cellular function is very important in bones and the cartilage of your bones. Now we're talking manganese. It's a very important element with the promotion of growth and development. You need in your growth and development, you need manganese every day. So cellular function, every cell in your body function, this is function needs manganese. In your bones and the cartilage, you know the bones, the two bones here is with cartilage connected to it. So cartilage here is very important. In your backbone here, you have a vertebra, and everyone have between them is cartilage. Between your vertebra is very important for needed manganese. So it takes part in metabolic reaction. Metabolic reaction every day you are eating. Metabolic reaction is needed. Excess of manganese lead to excess of blood. Excess leads to excess of blood. It's very good. May causes neurological disease, but if you more excess, it may causes neurological diseases, or if inhaled into the lungs, especially if enter to the lung, maybe something is very dangerous for you. So selenium is a very rare earth element with prevention of the vascular and other diseases. Neutralize the cells oxidation and the aging action of free radicals. It's a very antioxidation. It's going to be by selenium is the prevention of this is free the harm of free radicals, which causes some disease. Excess turn nails and hair brittle. Your nails here may be brittle if you have less amount of selenium. So the other one is zinc occur in all tissues. All tissues needed zinc, mostly in bones, muscles, and the skin. Active in the immunological system. Zinc is the most important element in your immunity of your body, especially today with corona. You must take in zinc in your food because it prevents your corona diseases. It's a very immunological system stronger. So regulates body growth, protect the levels. Your liver is the biggest factor in your body is the liver. Deficiency of zinc may be reduced body growth. So what is called تقزم, deficiency reduced body growth, causes عملية التقزم. Okay, now we're talking about a big mineral, big elements here it's aluminum here. If you don't see it, we're talking about aluminum. Aluminum non-essential despite its crystal abundance. برغم انتشاره الكبير, despite its crystal abundance, interferes with the and reduce assimilation of the phosphorus and the fluor. So it maybe causes some deficiency with the phosphorus and fluor, causing bone demineralized, suspect of the influence of Alzheimer's disease. Deficiency maybe maybe causes some excess of them in the Alzheimer's disease. Alzheimer is especially in old age. Arsenic is essential or not essential. Excess is cardiogenic. Excess may be making heart cardiogenic disease. Beryllium, non-essential, also toxic when inhaled as a dust. When are you going to beryllium inhaled in dust, it may be some toxin. Cadmium, also non-essential, toxic and carcinogenic, interference with zinc, inhibiting the normal assimilation of zinc. Mercury, non-essential, is the poisonous, of course. Nickel, essential to vegetable, possibly also to the animal. Nickel is essential for the vegetable growth. Lead, non-essential, but it's toxic. Stibnite is non-essential. Tin is non-essential. Titanium, non-essential. Vanadium, essential, extends its teeth life. Used teeth life, okay. Excess maybe causes lung disease. Yeah, so vanadium is dangerous for your lung disease, especially in corona time now. Okay, I will continue with you. So, common pathway of the element to reach your food chain. How this is element we discussed before coming to our foods. You know from this plant grows here after he decay or die or something like that. Soluble elements are assimilated by the vegetation or drunk by the animals here. Drunk by the animal. When animal drink water, it must going to be making element in the vegetarian or vegetation process. So we have here a plant, a soil, what is called the weathering process here. And plant evaporation is going to be coming, and the volcanic and the other dust coming also settlized here or rest here on water coming from volcanic and other dust. So it's all this is element here from weathering process transported by underground water here also from the sea, and also this is sediment decay. Here in the bottom we have metamorphic and sedimentary or igneous rocks. So this is the circle of the element here. So the plant absorb the element from the soil which contaminated us after that. Assimilation or ingested by the aquatic biota, coming igneous rocks here. Destroy by the aquatic biota here. Aquatic biota going to transfer by chemical weathering here. So all this is element making one trickle which reaches to us through what is called the breathing of dust or the eating of fish. Anthropomorphic action not considered. Okay, what is the contamination for the water and the food? Contaminated water reflects the chemical composition of the underlying materials here. So vegetation reflects the chemical composition of the soil where they goes. The animal, of course, eating, this is vegetation, for their water and food eating, reflects the chemical composition of the region where they live. Okay, every area characterized by some elements specialized in this area. So population feeding in this plant exclusively of locally produced foods are more affected by geochemical animals. Geochemical animals may be causes from the our rocks coming to us. There are classic causes of health problems due to the abundance or the lack of the elements as iodine, arsenic, selenium, zinc, and others. So it seems recommendable to consume the it seems to consume treated water and food from the variable sources. It seems recommendable. Yeah, it seems recommendable to the consumes treated water and food from the variable sources. Okay. Pollution as a source of the anomalies. Natural pollution coming from two factors here: volcanism and dust storm. Like in Pinatubo and Quito in Ecuador. This is dust storm and volcanism here. Anthropomorphic process, which is not natural. Industrial rejectors, coming from factory, marine rejectors, insecticides, desertifications, urban centers, and other factors like in Africa and something like that. So grades of the geological materials here in situ. Grade of geological materials, total of them in situ, grades of an elements. Okay, we totally bioavailable, which are coming from biology. Fraction available of the assimilation by the live organism. What is the grades? What is the grade degree of geological material transfer? So absolutely bioavailable. Yeah, of course. Fraction actually assimilated by the specific living organism. So more frequently examine the elements which are in soils and in vegetable, maybe as aluminum, arsenic, beryllium, cadmium, chrome, copper, mercury, nickel, lead, selenium, and stibnite, or plus what is called silver, barium, cobalt, manganese, molybdenum, sodium, titanium, vanadium, and zinc. So total initial content, it's here total of bioavailable and not bioavailable. It's bioavailable and not bioavailable. So it's bioavailable. It's divided into absolutely bioavailable and not assimilable, not assimilable for the specific organism here. So weathering of source rock, of course, as you know, liberate metals. Okay, when rocks are coming to making weathering, liberates or donates metals, so it's and the metalloids to the soils, of course, and the water and the atmosphere as a dust, as new minerals. So residual minerals in solutions. Residual mineral in solution absorb as organic and inorganic activity complex and as a vapor, of course. So all elements in the nature can be released in the weathering process. We have, from your information, we have two types of weathering: chemical weathering and physical weathering. So all these elements can be released or liberate from the source. Weathering is strongly dependent of the local climate, according to temperatures and something like that, and the action of living organisms. What is the animal or planet transportation of the metals from one side to another one? Carbonate and oxide, hydroxide, oxide or hydroxide, carbonate oxide and carbonate hydroxide of the metals like iron and manganese predominate among us is the new crystalline form of metal and metalloids. So it's very important element in iron and manganese. Clay mineral are important for the absorption of metals. Clay minerals are important for absorption of metals and metalloids. So it's the soil. Clay mineral, we're talking about the soil. So example of bioavailability, the maximum agricultural productivity coincides with the greater bioavailability of potassium here, potash here. Roca, some roca here, like types of figures here of our vegetable. Colinita, zebista. Some foods you have here in soil profile the peak concentration of potassium here, the peak concentration of potassium here, and where cementite predominant here, productive. So potassium here is high, here is low. So we can the maximum agricultural production will be greater availability of potassium. This is potassium here is found. Low bioavailability or metal strangulation. Low bioavailability or metal sterilization or on a lateralization. So here zone A, yellow. This is the section of the soil. Zone A, yellow clay rich in silicon dioxide here, what is called sand here, leaching of magnesium coming, leaching of magnesium coming, calcium, potassium, sodium, copper, zinc, and others concentrated in this is zones of soils. Zone B, argillaceous and common. Zone B, argillaceous and concretion. Zone B, argillaceous and concretional area rich in aluminum and iron with manganese, arsenic, cobalt, selenium, zinc, and nickel retained within ilmenite. Within here is ilmenite, leached of magnesium, and calcium, sodium, and other. Zone B, it's hard bed rocks, it's fresh rocks, or this is different bed rocks. Argillaceous saprolite with the gradual physical and chemical transportation of the fresh rocks below here. Grades of magnesium, calcium, sodium, potassium, copper, nickel, and other increase towards the base. So this is the fresh rocks, which all metals after weathering transfer from bottom to up here. Water with the solvent metals accumulate towards the base. Here, of course, this have much water than this. This water coming also from the rains or from the ground water. So, bioavailability of elements to the biota. It is influenced by the climate, depend on the climate, pH, degree, oxidation potential, the biota, which is composed of vegetation of microorganisms, etc., mineralogy, temperature, specialization of the element, interference between the elements, what is the relation between copper, when iron, more molybdenum, zinc, etc., what is the relation between these two groups. Occurrence of salts increase the bioavailability of the metals from smaller to greater. Salt, of course, here. Lead oxalate, lead carbonate, lead acetate, lead sulfate, lead sulfide. This is all compound of lead here, which may be availability of elements according to the salt increasing bioavailability of these metals. So metals solubilized, metal solubilized as cations, and are more bioavailable in acid waters. So metal solubles as cations. Cations, you know, it is have positive charge. Metal solubilized as oxyanions. Oxyanions, it's going to be negative charge, as arsenic 5 and molybdenum 6 and oxides of chromium are more bioavailable, essential basic water. So molybdenum here, molybdenum and copper, copper and iron, phosphorus oxide and zinc, zinc and cadmium, sulfur and selenium. So increase in soil, increase molybdenum and the copper in soil, pH increases. The mobility of molybdenum in relation to the mobility of copper. What is the relation between mobility of molybdenum and the mobility of copper? The relationship here, reducing the capacity of the vegetation. Okay, vegetable is less, so it is to assimilate copper, with the bad result for the animals and the humans. Okay, presence of copper or molybdenum increase soil pH and making problem for animal and human. So copper and iron, the presence of copper and the possibility of nickel and is necessary for the proper action of Fe in metabolism. The phosphorus and zinc, increasing of phosphorus oxide in soils reduce the capacity of vegetation to assimilate like molybdenum and chromium. This is increasing to reduce the capacity of vegetation to assimilation with zinc, with the terminal with detrimental results for the animals and human. Zinc and cadmium, increases of zinc reduce the capacity of assimilation cadmium by the vegetation, animal and humans. Sulfur and selenium, the uses of sulfur rich fertilize which are المخصبات التي توضع في التربة, reduce the capacity of vegetation for the assimilation of selenium. Okay, if you are increase the sulfur fertilize, you will be prevent the selenium coming to your soils. Vegetation for assimilation of the soils from you prevent the plant to absorb the selenium from the soil, with the bad effect of animals and humans. Of course, the deficiency of selenium causes some diseases. So what is the toxicity like Brazilian norms? Brazilian norms as example. What is the test here making? Test in neutral solution pH, test in duplicate H with 100 gram of sample, permanence times of 7 days after strong initial agitation, final solution dilute to this is the method. What is the test done? Leaching test, mobilization test and leaching test, test in acid water. This is the norm. Okay, what is the solubilization for an consumption? Here the method Brazilian one. What's its pollution in our food? Okay, so we have from southwest here, southwest to northwest, and some arsenic in the Sierra and Navio manganese ores, some making some default. Yeah. Also arsenic solubility may be some diseases here. So now we are reaching to what is called the pollution of the element and distribution in the soil and the vegetation. We discuss here the bad effect or the what is important for the growth. So we need now to review this lecture, and you know what is the important element for you and what is the element causes for you some disease. Thank you very much for your listening, and bye-bye. See you later in the next lecture. And have a good time for the exam of midterm exam. Thank you. Bye-bye.